Hello friends, now let us start the next chapter of your production engineering, that is the metal casting. Metal casting is one of the most important chapter of your production, and in the GATE, as you all know that in the GATE the weightage of production engineering is around 17 to 18 marks, and from these 17 to 80 marks you will get 2 to 3 marks question from the metal casting every year. So this is a very important chapter of your production engineering, that is metal casting, and we will study in detail that what is the metal casting, what are the various types of casting, what are the various time or you can say the time of solidification and all, and what are the various allowances in the casting, what are the various defects in the casting and all, we will discuss in detail. Now first of all, let us see that what do we mean by metal casting. Right, metal casting is also one of the manufacturing process in which we will manufacture a product. Right, so in the metal casting, if I can write the definition of a metal casting, so we can say that metal casting is a process, it is a process, if I can write, it is a process in which molten liquid or you can say molten liquid, it is a process in which molten liquid metal, right, we will convert the metal in liquid form, molten liquid metal allowed to solidify in a predefined mold cavity. Right, I'll explain it. First write the definition. In a predefined mold cavity. Right, so this is the metal casting. In the metal casting, what we have a pattern. Right, the pattern, we can say that pattern is the replica of the product which you want to make. Right, suppose I want to cast a product of this pen shape, so I will make a pattern of using wood or some plaster of Paris, some wax, so many pattern material is available. So I will make a exact pattern, exact replica of this pen, and I will put this pattern in the sand, and we will make a mold cavity. A cavity is made just like this, your pattern, just like this marker, your mold cavity is made. Now in that cavity we will pour the liquid metal, the metal of which I want to make this pen. Right, suppose I want to make this shape with the help of some iron. I want to make this pen of iron. Right, so I will pour the iron in that mold cavity, allow that molten iron to solidify. After that I will break the mold cavity, take out this product. So this product is now called as casted product. So this is a casting. Right, so in the casting, the most important thing is first we have to make a pattern. Once you make a pattern, then with the help of that pattern you can make a mold cavity. In that mold cavity we will install some of the riser or gate. We will discuss it in detail later on. So in that mold cavity, through the sprue or through the pouring basin, I will allow the molten metal to enter into this mold cavity. We will allow this molten metal to solidify. It will take some time, let us say 1 hour or 2 hours. After that we will break the mold cavity and your product is there, and this is known as casting, and this product is known as casted product. So this is the basic definition of metal casting. Right, so we can say that in the metal casting we will have this, first of all, this mold cavity. Most important is we have to make this mold cavity. Right, how we can make this mold cavity? This mold cavity can be made with the help of a pattern, a replica we have to make. With the help of that pattern we can make this mold cavity and then allow this molten liquid metal to enter into this mold cavity. right? This is a basic your metal casting. Now if I will say that this mold box, right, if we will say, suppose this mold box, if I can write here, this mold box is of two types. Mold cavity, you can say this mold box is of two types. First one is two box. First type is two box. Mold box is of two types. First one is two box and second one is three flask. Three flask. This mold cavity we can make like two box or three flask. In the two box we have two these kind of a box, right? Two box we have like this, right? This is a mold cavity, right? This complete is a mold cavity. I can say that this upper part, this upper box is known as cope. This upper box is known as cope and this lower box is known as drag. This lower box is known as drag, cope and drag, right? We have a mold cavity in between, so this is a cope and drag, and this line, this parting line, this line is known as parting line. This line is known as parting line. And suppose the mold cavity is something like this. If I will make a mold cavity, suppose a mold cavity is here like this. This is the mold cavity in which we will fill the molten liquid metal. This is a mold cavity, right? If I can write here, this is your mold cavity. Mold cavity, right? This is a mold cavity in which I will fill the molten liquid metal, and this cope and drag will be made of with some molding sand. Here we have molding sand. Here you have molding sand. This mold cavity can be made of some sand or green sand is there. This is your molding sand. Molding sand, right? So this will be look like a casting product. So this is your product, and in this mold cavity we will fill the liquid metal, and after that, after solidification, we will break these two boxes and take out this product. So this is the example of your two box. In the three flask system, we have three cavities. We have three box, something like this. We have three box, something like this, right? In between we have some mold cavity. This upper box is known as same, that is cope. This lower box is known as drags, similar to the two box system, and this one is known as, this middle one is known as cheek. This middle one is known as cheek. So we have two types of mold box, two box system and three flask system, right? Basic definition, and we will discuss what is cope, drag, parting line and all in detail later on. So this is the basic type of your metal casting, basic definition of metal casting, right? Next if I can say that, now let us start with sand casting. One of the most prominent casting type is sand casting, right? We will explain what is this sand casting. Sand casting means that mold cavity or this mold is made up of sand. That mold is made up of sand. Suppose if I can say, what is the meaning of sand casting? Let us say this is a mold cavity, this is cope and drag. So here we have sand. Here we have sand. So this is a sand casting. Here we have sand. So this is a sand casting, and here in between we have some cavity. Some cavity is there. So this is the sand casting. So this mold is made up of sand, right? Now let us see that what do we mean by sand casting, right? Let me remove this. Now let us talk about what do we mean by sand casting. So sand casting uses ordinary sand. It will use ordinary sand as the primary mold material, right? Your primary mold material is your normal sand, ordinary sand, which is available. Next, the sand grains are mixed with some small amounts of other material. Some amount of other material we have to mix with the sand, which will be act as a binder, because we have to make that sand to bind with itself so that they will make a compact structure. So some material we are mixed with the sand. These material are, let us say, clay and water. Clay and water we will mix to improve the moldability and cohesive strength. To improve the moldability and cohesive strength, and are then packed around a pattern that has the shape of the desired casting, right? That has the shape of the desired casting. What is the process which we are doing? I will explain it. Just see. What I am saying is, suppose you have to make a casting. Suppose you have to make a casting of this shape. Suppose you have to make a casting product of this shape, right? This shape. I want to make a casting product of this shape. This is my product. So what I will do, I will make a pattern of using wood or some metal or some wax, some plastic, plaster of Paris. So many pattern material is there. So I will make a pattern of the same shape and same size. So suppose this is a product and I am making a pattern of the same shape. Let us say this is our pattern. Now let us say this is our pattern. Right? This shape I want. This product I want. What I can do? Now I will pour this molding sand on this. Now I will pour this mold sand, this ordinary sand on this. On this pattern I will pour some sand. Let us say this black color will represent the sand. Here we have some sand, right? Sand, and I will mix some clay or water in this, which will be act as a binder, right? This is the sand, molding sand. This will be a sand. Now to make this compact, we will use a process that is known as ramming. We will use a process that is known as ramming, right? Ramming. We will just ram this sand so that it can stick to the pattern. It will take this shape of the pattern and it will become a compact shape. So I will use this ramming, right? Ramming is a process which will be used to strengthen the mold. It is a process to strengthen the mold. It will strengthen this mold and it will make this mold a compact structure, and it will make this just to stick with this shape of the object, of the pattern, you can say. Now this ramming is done with the help of a tool which is known as draw spike. We have a tool which is known as draw spike. With the help of this draw spike, we will ram this. Once it will take the shape of this, I will remove the pattern, and in place of this pattern we have a mold cavity. You can visualize we have a mold cavity. In that cavity I will pour the liquid metal, whichever we want, and it will take the shape of this mold cavity and your product will be there, right? So this is the way to make the casting. Next, if I can say, the pattern must be removed before pouring. Obviously, if you will not remove the pattern, then there will not be any mold cavity. The mold is usually made in 2 or more pieces. The mold which we are using is made up of 2 or more pieces, right? As we discussed earlier, we have 2-box system or 3-flask system. An opening called a sprue hole. An opening called a sprue hole. If I erase this so that you will be better see this one, just because I make this just to understand that how the casting will be there. Right, now an opening called a sprue hole. We have to make a opening in the mold cavity, that is sprue hole is cut from the top of the mold through the sand and connected to a system of channel called runners. Right, in the gating system we have sprue, pouring basin, runner, gate, so that the molten liquid we will allow the molten liquid to enter into the mold cavity through the sprue and through the runner. Right, we will discuss in detail that what is the sprue and what is the runner. For just now, just see that a opening called a sprue hole is cut from the top of the mold through the sand and connected to a system of channel called runners. Right, we have some runner and a sprue hole. Next, if we can say that the molten metal is poured into the sprue, you will pour this molten metal into the sprue hole, flows through the runner and enters the mold cavity through an opening called gate. You have to remember this. We have a sprue hole, we have a runner, and we have a gate, and molten metal will flow from sprue to runner to gate and it will enter into the mold cavity. Gravity flow is most common meaning of introducing the metal into the mold. Right, we will use the gravity, and there is no other method to make this cavity filled with the molten metal. We will use the gravity only. So gravity flow is the most common. The molten metal is entered into the cavity with the help of gravity force. After solidification, the mold is broken and finished casting is removed. Right, after solidification you can remove the finished casting. The casting is then fettled. We will see that what do we mean by fettled, by cutting off the ingate and the feeder head. Right, fettle means fettling process means removing the extra material from the casted product. That is the meaning of fettled. An extra material is there in the form of your ingate, runner, feeder head. Right, these will be the extra material and you have to cut these material. This is known as fettled. Because the mold is destroyed, a new mold must be made for each casting. In the sand casting, this is the disadvantage, that in the sand casting every time you have to make a new mold, because to remove the product after solidification you have to break the mold, and if you break the mold then your mold is destroyed, so you have to make a new mold after every casting. This is a basic design of a sand casting. I will explain here some of the common thing. See, these are the two boxes. Suppose this is the top box, let us say this is the cop and this is your drag. This is your drag. In between we have some mold cavity. Suppose this is a mold cavity. Sorry, this is the riser. This is the runner. This is your runner. It is written here, I will write if it is not visible. This is the runner. I am introducing the molten liquid into this runner. This is the molten liquid. Molten metal you can say. And we have a riser here. This is the riser. This one is riser. Right, and in between we have some mold casting. We have some mold cavity. Right, if I will show you like this, if I make these two boxes separate, so this is the sprue. This opening is known as pouring basin, or not pouring basin, I can write. This is your sprue. This is known as sprue, and this is known as runner. This is known as runner. This entry in the mold cavity, this entry in the mold cavity is known as in-gate. This is known as in-gate, right? And here we have riser. Here we have riser. Here we have riser, right? Now, so we can say that if you pour the molten liquid here, then after solidification you will get this casting. You will get this casting. Suppose in this diagram, if you will not confuse with that, right? In this diagram, let us say that this is the cavity, so that there should not be any confusion. This is the cavity, this is the riser, and this is the sprue. Let us write here. This is your sprue. This is sprue, and this is the cavity. If I highlight this, this is the cavity. This product you want. Up to here, this product you want, right? So after solidification, what you will get? You will get this sprue, this product, and this riser. This complete will be taken out. This complete is a casting product, right? This complete is a casting product, but how much we require? We require from here to here, right? Only this product we want. Only this product we want. So we want to remove the extra excess metal, like this sprue and this riser, we want to cut it. This process is known as fettling. This process is known as fettling. You can cut it with the help of some cutter and something else, right? You will cut it with the help of some hexa or anything. Then this process is known as fettling. So this is a casting product. This is a casting process, right? Now, if I make a generalized diagram for the casting, right, let us make a generalized diagram for a casting. 1 second. Right, let us make a generalized diagram for casting. The casting product, casting diagram will look like this, something like this. I will make it. Just 1 second. After remembering this diagram, you will be able to understand it better. Yeah, I'll draw a diagram of casting so that you will be able to visualize how the casting will look like, what are the various elements in the casting, right? Let us draw a diagram. Right. First, let me draw the diagram. This is the runner. This is a cavity. Wait. Okay. First of all, let us see that it will be something like this. It will be extended up to here. Here we have a something like this, right? Here we have some skim bob shape, something in between we have this shape. Each of these elements have a specific function. We will discuss it in detail. Here we have gate, or you can say in gate. After that you have the mold cavity. Right, after that we will have this is the mold cavity. Something like this. Wait. Something like this, we have a mold cavity. Here we have riser. Right. If I name it, if I name the various parts of this is your pouring basin. This is a casting. This is the basic elements of casting. This is known as pouring basin. Pouring basin. Right, this is known as pouring basin. Here we have a strainer. Some mesh type object is there, which is known as strainer, which will remove the impurities or foreign material present in the molten liquid. This is known as sprue. This is known as sprue. Right. This is known as sprue base well. Sprue base well. This is known as runner. This is your runner. Right. At the bottom of this sprue base well, we have this shape which is known as splash core. Which is known as splash core. This is runner. This is known as, these bulged is known as skim bob. This is known as skim bob. This entry into the mold cavity is known as gate, or you can say in gate. This is your cavity, the product which you want. This is your riser. This is your riser. And around this, here we have, this is the molding sand. Here we have molding sand. Molding sand will surround this, all this. This is the molding sand. Right. So once the casting is completed, all these will be a part of your product. When the casting will be completed, when the metal will solidify, this complete white color, everything will be a part of your product. After breaking the mold, you will get this complete shape. You will get this complete shape. But in actual, what we want only this mold cavity. We want only this object, this product we want. So you have to remove this extra material, riser and all these part, you have to cut it from the product, which is known as fettling. So this is the shape of this is the generalized diagram of the casting. You have to remember this, and we will discuss all the functions of all these parts in detail later on. Right now. So this is the basic diagram.